Hey guys, we are still dealing with graphing quadratic functions, except we're going to explore two more forms today. So we're looking at vertex form and we're looking at intercept form. So first, you want to probably type these into your graphing calculator and try these out. What happens in the following transformation? So pause the video, take a second, type it in with the parentheses, and see what happens. Hopefully you're back with me and you discovered that this moves right 3 and this one moves down 2 instead of the up or down when it was outside. And also when it was outside, it moved. If it was a minus, it moved down. If it was a plus, it moved up. But you'll notice these are backwards. So the minus made it move to the right. The plus, oh, sorry, that should not say down. The plus made it move to the left. I was already trying to make my comparisons and didn't pay attention to what I was writing. So that moves left too. So that leads us into vertex form. Vertex form is right at the top there. Looks like y equals a in parentheses x minus h, quantity squared, and then plus k. The really nice thing about vertex form is your vertex is given to you in this form. It is h and k. Now you have to be careful since it's x minus h. And then the axis of symmetry is x equals h. So in this graph, our vertex, we have x minus 1. So our x value is a positive 1, since it's x minus h. And then we have plus 3. So our y value is 3. So your vertex is 1, 3. We're going to do the same thing we did before. And we'll be able to graph. I'm going to put 1 right in the middle. And then, so 1, 3. I'm going to go to 0. Plug in 0. 0 is not necessarily as easy to find in this form, but you can still find it. And then I'm going to plug a negative 1 in, and then 2 and 3. You can pick whatever you want. If you want to pause the video and come up with these yourself, and then check with me in just a second. So I get 0 is 5, 2 is 5, 3 is 11, and so negative 1 is also 11. One thing that's happening from your original is we've moved to the right 1 and we've moved up 3. I can also tell by our A value that we had a vertical stretch of 2. We multiplied by 2. That 2 up front is what tells me that. My axis of symmetry, for practicing graphing this, is x equals, and it's my h value. It's at that vertex. So axis of symmetry here is x equals 1. So remember an x equals, think back to Hoyvux that you learned in Algebra 1, x equals, that's going to be a vertical line at x equals 1. So if I plot these points, I'm going to go over 1, up 3. I'm going to go over 0, up 5. And then also over 2, up 5. And I don't think this is going to quite fit. There's 10, so I'm up a little bit off this graph. And I'm going to connect. And my axis of symmetry is going to be right here. So this is x equals 1. Alright, use a graphing calculator to estimate the x-intercept. So right now type each of those in your graphing calculator and find where they cross the x-axis. So it's where y is 0. Those are the x-intercepts. So pause the video right here and find where they cross. Alright, hopefully you are back with me and you have discovered that here x is -2 and x is 4. And on this one, x is 3 and x is -2. So hopefully you notice the pattern there. This is leading us into our third form, intercept form. So intercept form looks like that equation that you see up there, y equals a, and then parentheses x minus p, parentheses x minus q. Your x-intercepts then are p and q, or p, 0, q, 0, if that's where you are writing the point. The axis of symmetry is halfway between points p and q, the midpoint of the intercepts. So those intercepts are the same distance apart, and so your axis of symmetry and your vertex then will be halfway between. So for graphing this, we have x minus 3, x plus 1. So you don't necessarily need 5 points here if you can get away with finding the intercepts and the vertex. That's probably enough. So one of our intercepts then is 3, and then our other one is -1, and that's where y is 0. That's what the intercepts mean. So halfway between 3 and -1, well, you can do 3 plus -1, and then you're going to divide that by 2. So we get 2 over 2. So halfway between is 1. So then I'm going to plug 1 in. So I get 1 minus 3 and 1 plus 1. So 1 minus 3 then is -2. 1 plus 1 is 2. So 2 times -2 times 2 is -8. So I'm going to graph over 1 down 8. Over 3, I'm not moving up or down, and then over -1, I'm not moving up or down. So there's my graph, and my axis of symmetry is going to lie right here at x equals 1. All right, write a function in standard form. So remember, standard form is y equals ax squared plus bx plus c. So we need to take this form, which hopefully you recall and notice is vertex form, and change it over to standard form. So what I noticed first, and what you need to be very careful of, is when you see this squared here, that means we're multiplying the same thing twice. So x plus 2 and x plus 2. Okay, so when we do this, you can FOIL. So I'm going to leave my half alone out here. And I have first is x squared. That's this. Outside is 2x. Inside is 2x. And last is 4. I'm going to simplify what's inside there. So I get y equals 1/2 x squared plus 4x plus 4. And I'm going to take that 1/2 and distribute it out. So I get y equals 1/2 x squared. Now it's a plus 2x. Now it's plus 2 minus 3. So positive 2 minus 3 So 1/2 x squared plus 2x, now I'm at a minus 1. There's my answer in standard form. We are going to stop there for today. If you have questions on anything, please come in and see me. I will see you all in class.